Wow, I promise that we are going to get to this point as far as sum and product of roots of quadratic equation is concerned. Welcome to Further Mathematics Meal. Today on Further Mathematics Meal, we are going to look at finding values of expressions given in terms of what? Roots of quadratic equations. Now, in some cases, we may be given certain expressions in terms of the roots of quadratic equation, that's in terms of alpha and beta, and we are expected to actually find the values of such expressions. We're going to use the knowledge of sum of roots and product of roots to handle such problems. Okay, so to find the value of any expression given in terms of roots of a quadratic equation, we take these steps. So if we're given any particular expression that is given in terms of what? The roots of quadratic equation. Because of space, I can take care of this portion so that we understand what we are trying to talk about. If someone asks you to find the value of 1 over alpha plus 1 over beta, now this is an expression. Evaluate this. Now these are the roots of what? Quadratic equation. So once we have this type of expression, we can actually find the value of this type of expression using the knowledge of sum of roots and the what? Product of roots. Yes, we can. So that's what we are trying to do here. When we're giving expressions in terms of what? In terms of roots of equation, how can we find the value of such expressions? By applying the knowledge of sum of roots and product of roots. So how do we do that? We say we are going to take these steps. What are the steps? These steps are very important to us, so we can actually leave the steps. So number one, the first step is to take note of the quadratic equation. So in such question, a quadratic equation will be given to us, so we take note of the quadratic equation. Number two, using the quadratic equation, find the sum of roots and product of what? Of the roots. So using the quadratic equation, that's step number 2. We do that. We're going to apply these steps to this question now. Okay, then transform the word expression to be in form of sum of roots and product of what? Roots. So we transform the expression to be in form of product of root and sum of root. Substitute the sum of roots and product of roots to obtain your word, your answer. Now, there are certain expansion that are very, very important. Expansion rule, you know, in algebraic expansion in mathematics, we have a lot of rules, like sum of roots, just like we have here. Where is it? We have sum of what? Sum of roots. We have sum of cube, and so on. So, and we can also have difference of cube. We can also have difference of two squares. Okay, difference of two squares. You have difference of two squares. Alpha square minus beta square is actually alpha plus beta, alpha minus beta. Why we need to know this rule is because there are certain expressions we may want to evaluate, we may want to find their values, we may require the knowledge of this word expressions. Just like I didn't include difference of two square because already I have this. So if I know this and then this one is known, this is already sum of root, you don't have problem. Okay. So let's look at the equation we have. So you need to master this. Alpha square plus beta square. This is not in form of sum of roots. What we need is sum of root and product of root, because we can only find sum of root from a quadratic equation, and we can only find product of root from a quadratic equation. You see that? So every expression given to us, we must try as much as possible to express it in terms of what? Sum of root and the word and product of root. So if someone now say evaluate alpha square beta plus alpha beta square, this is not sum of root and this is not product of root, because this one is product of alpha square and beta, so it's not this. But I can actually transform that to be in this form: alpha beta bracket I'm going to have alpha plus what again? Beta. So you now see that this is product of root, this is what? Sum of root. So I have transformed this particular expression in terms of what? To be in terms of what? Product and sum. Then I can substitute product and sum. And that's what we are trying to do here. You see this now, we can't really find the value of this because we don't have any rule for alpha square plus beta square. All we have is that alpha plus beta is b over a and alpha beta is c over a. We don't have anyone like alpha square plus beta square is maybe b square over a square. No, we don't have such rule. So when we have expressions, we try to put them in the form of alpha plus beta and alpha beta. Yes, because these two are the only possible values we can obtain from the word quadratic equation. So we cannot actually solve this unless we first of all reduce it to be in form of sum of the root, and then here I have product of the root. I can't handle this unless I first of all reduce it to sum of root. You see this one is still sum of root squared, and I'll say if I can put the sum of root and square it, and then this one is still in terms of what? Product of root. So to handle any of this expression, this is the key. Transform the expression to be in form of what? Sum of root and product of what? Root. If you cannot be able to transform any expression given to you to be in form of sum of roots and product of root, then you cannot solve the problem. So like here we have 1 over alpha plus 1 over beta, right? There is no rule of finding 1 over alpha and 1 over beta, but we can transform 1 over alpha and 1 over beta plus 1 over beta to be in terms of what? Alpha plus beta and alpha beta. Okay, so let's take these steps and begin to solve this problem. So, solution. Take note of the quadratic equation. What is the quadratic equation? We're given 2x squared, right, minus 7x plus 6, right, is equal to 0. Okay. After taking note of the equation, using the quadratic equation, find the sum of root and product of root. In the previous video, we saw how we can find sum of root and product of what? Root. We first of all identify the a, b, and c, and then use them. So what is my a here? My a is 2, my b is minus 7, and my c is what? 6. Okay. So let me find sum of root. What will be alpha plus beta here? Alpha plus beta is minus b over a. So in this case, alpha plus beta will give me minus, b is minus 7, minus 7 over a is what? 2. So alpha plus beta is actually 7 over 2, because minus times minus is plus. So what is my alpha beta? So I think these two steps are taken care of. So let's remove them. So what is my alpha beta? So this expression alpha plus beta 7 over 2, very important. So what is my alpha beta? Alpha beta will be c over a. C over a. What is c? C is 6. What is a? A is 2. So we have what? 3. So alpha beta is 3. Okay, so we have taken note of the equation according to this step. The next step is to find the sum of root and find the product of root using this. Then the next step, transform the given word expression to be in the form of the word roots, sum of the root and the product of what? Root. So we transform. So the first expression given to us is 1 over alpha plus 1 over beta. If we transform this expression, what are we going to have? To be in form of the sum of roots and product of roots. Okay? What's the LCM? You know that this is 6 over 2, which is 3. So we'll keep this. This and this are very important. So let's find LCM here. It is alpha beta. Alpha divided this is beta. Beta times this is beta. Plus alpha divided this is alpha, beta divided this is alpha, alpha times this is this. So it means that 1 over alpha plus 1 over beta is the same thing as what? Beta plus alpha over alpha beta. That's what you have. Now we know that beta plus alpha, based on commutativity, beta plus alpha is something as alpha plus beta. We know that because 2 plus 3 is 3 plus 2. So in addition, the order, the first one or the second one doesn't matter. The order of arrangement of the numbers in addition doesn't matter. So beta plus alpha is something as alpha plus beta. They are the same thing. So it means that I can still write this as alpha plus beta over what? Alpha beta. Now we take this step. Now we have transformed the whole of this to be in form of sum of root and the word product of root. This is, they asked us to find the value of this, but we cannot actually find it because this is not in terms of sum of root and product of root. So the first thing we did is to transform this. We have expressed this in terms of what? Sum of root. We can see these the two roots, and then in terms of their product. Since we have done that, the last step is substitute the sum of the root and the product of the root to obtain your answer. So what is the sum of root that we obtained before? It's 7 over 2. So this becomes 7 over 2 sum of root alpha plus beta divided by product of root, which is what? 3. So if we do that, 7 over 2 divided by 3, which is actually 7 over 2 times 1 over 3, which is 7 divided by what? By 6. That's what we have. Okay? Then the B part of the question, we are asked to evaluate this. Already we have an expression for that. So we cannot evaluate this without transforming it to be in terms of what? Sum of roots and product of roots. So alpha squared plus beta squared. We can only use sum of root and product of root to evaluate this when we put this expression in terms of sum of root and product of root. So which other way can we write this? Because we cannot find this. The only thing we know the value of alpha plus beta and alpha beta. And this is not alpha plus beta, and it is not also alpha beta. So I can't find the value of this expression except I transform this and express this in terms of this and this so that I can substitute the values. So alpha squared plus beta, I can write it as alpha plus beta all squared. Let's bring it down here for space. Alpha squared plus beta squared will be alpha plus beta all squared minus 2 alpha beta. That's what it means. Maybe later I will take our time to explain why this is this. If you do the expansion, you also see it. Yes, you'll see it. Okay? So alpha squared plus beta squared is alpha plus beta squared minus 2 alpha beta. So this is straight. Already we have alpha plus beta. So what is alpha plus beta? 7 over 2. But here this alpha plus beta then squared. So 7 over 2 all squared minus 2 alpha beta. 2 alpha beta. So 2 times alpha beta. What is alpha beta? 3. That's alpha beta. So that will now give us what? That will give us 7 squared is 49. 2 squared is 4. Minus 2 times this is what? 6. So if we subtract this over 1, 4, we're going to have 49 minus, we're going to have what? 24. Yes. So this will give me 49 minus 24 is 25 log of 4. So alpha squared plus beta squared will give me 25 over 4. Wow. That's it. So subsequently, now I believe you have taken note of the steps. So in our next videos, we will now be solving questions. At least we'll solve as many questions as possible so that we make sure that you digest this and it becomes part of you. Thank you for watching this particular aspect of our mathematics and science. Remember, I promised you that further maths will now be coming more often. Yes, we'll be bringing further maths. It's not just pure mathematics alone, because we discovered that many students are having challenges in the hard maths. So let's also give that aspect of our class that I give it maximum attention. Yes, we have to, because many students, if you want to study engineering, definitely it's important that you do further mathematics at your secondary school level. Thank you for following us. Remember, I'm your friend and your brother, Engineer I. Okechukwu is my name. I love you.